Hello friends, welcome all of you. Today we will discuss with you Diels-Alder reaction. Okay, this is one of the most important reaction in the organic chemistry. Generally, the 1,4 addition of an alkene to conjugated diene to form a adduct of 6-membered ring or the cyclic product or the cyclic component is called as a Diels-Alder reaction. What I have said, 1,4 addition of alkene to conjugated diene to form a 6-membered cyclic ring or the cyclic product is called as a Diels-Alder reaction. Okay, these reactions are carried out in presence of heat, so it is called as a thermal reaction. Sometimes reaction may carried out in presence of the Lewis acid catalyst. Okay, so these are two examples, out of which one is the 1,3-butadiene plus ethylene. Okay, this may be added here. This pi bond gets shifted here. This pi bond gets shifted here, and this pi bond gets shifted here. Okay, 2 new sigma bonds are found and 1 pi bond is found. 4 plus 2 pi cyclohexane take place at 473 Kelvin. Cyclohexane is found. Okay, so this is called a 4 plus 2 pi cyclohexane because this 4 pi electrons of a conjugated diene and these 2 pi electrons of a dienophile on the diene is involved in this reaction, so this is called as a 4 plus 2 cyclohexane reaction. This reaction also referred as a 1,4 cyclohexane reaction because 1 and 4 carbon of the conjugated diene is involved in this reaction, so it is called as a 1,4 cyclohexane reaction. Okay, another reaction is also take place likewise. Okay, this pi bond pair is shifted here, this pi bond pair of the conjugated diene is shifted here, and then 1 pi bond pair of the ethylene or the dienophile gets shifted here. Okay, generally alkene is referred as a dienophile in the Diels-Alder reaction. So 1,4 addition take place and the formation of the 1,4 cyclohexadiene take place. This is the example of a Diels-Alder reaction. Okay, so these are in Diels-Alder reaction, 2 compounds are very important. One is the dienophile and another is the diene. What is dienophile? The simple or substituted acyclic or the cyclic diene is called as a dienophile in the Diels-Alder reaction. Okay, so this is ethylene or ethene. This is monosubstituted ethylene. This is bisubstituted ethylene, where the X and Y may be electron withdrawing group. Not maybe, but it is a there may be electron withdrawing group. Okay, these electron withdrawing group may be carbonyl, aldehyde, COOH, cyano, nitro group. Okay, so dienophile having electron withdrawing group favors the Diels-Alder reaction, while the conjugate diene having electron donating group or electron releasing group favors the Diels-Alder reaction. Okay, so it may be triple bonded component. Dienophile may be triple bonded compound. It may be benzene. It may be cyclohexene. This may be trans 1,3-butadiene. Okay, and this may be allyl cysteine. These are also referred as a dienophile. The examples of the dienophiles. Okay, so dienophiles gives or shares 2 pi electrons in the Diels-Alder reaction. Okay, next component diene, that is conjugated diene. Okay, it must be conjugated and it must be cis form, and conjugated diene may involve a cyclic or the alicyclic hydrocarbon. In case of the alicyclic hydrocarbon, the double bonds may be partially or wholly the part of ring. Okay, so these are the example of the conjugated diene. Out of which one is the, these are the 2 examples of the acyclic diene. This is 1,3-butadiene. This is the substituted 1,3-butadiene. Okay, thereafter this is the cyclodiapentene. Okay, this is first, this is second, and this is third one. These are examples of the alicyclic components. Okay, or the alicyclic diene. Okay, sometimes maybe heterocyclic component may be involved as a Diels-Alder reaction. So this is the furan, and the number of times aromatic compound may be involved as a conjugated dye. So this is the anthracene, and this is aromatic compound. Okay, and this also may involve in the Diels-Alder reaction. Okay, these are about the introductory part of the Diels-Alder reaction. Generally, conjugated dye having electron releasing group favors the reaction, and the conjugate dye acts as an electron rich center for the dienophile. In Diels-Alder reaction, cyclic dyes reacts very rapidly than acyclic, because cyclic dyes exist in the naturally cis form. Okay, and acyclic dyes exist in the more stable trans form. So this is the example of cyclic dye. This is in the cis form. So these undergo more quickly Diels-Alder reaction than this 1,3 protein, which is the trans form. Okay, whenever there is a trans form, it may be converted into the cis form by heating. So this is the 1,3 protein trans form. By heating, the exchange of 5 chemical energy takes place, and it converted into the cis form, and that cis form of dye may undergo the Diels-Alder reaction. Okay, next one, when both dyne and dienophiles are unsymmetrical, then there is possibility of two products. What I have said, when the both dyne and dienophile are unsymmetrical, then there is possibility of two products, out of which the 1,2 and or 1,4 product may be measured. Okay, depends on the which substituted conjugated dye. Okay, so let us see two example. This is the one substituted conjugated dye, and this is the acrylaldehyde, like this is acrylaldehyde compound. Okay, so this is the dye and this is the dienophile. Okay, this carbon is shifted here, this carbon is shifted here, this carbon is shifted here. Diels-Alder reaction takes place, and two products are formed, 1, 2 and 1, 3. Okay, out of which the 1, 2 product is a major. Okay, and 1, 3 is a minor. This is one example. Let us see another example. Here is the two substituted conjugated dye is involved in this reaction, and this is the dienophile. Okay, so this carbon is shifted here, this carbon is shifted here, this carbon is shifted here. Heating takes place, and the two products are formed, out of which the 1 is a major, 1, 4 product. 1, 2, 3, 4. 1, 4 is a major product, and 1, 3 is a minor product. Okay, so depends on the substitution of conjugated dye. 1, 2 or the 1, 4 is a major product after the Diels-Alder reaction. Okay, next, the most important point, the stereochemistry. Okay, with the dienophile having the cis, stereochemistry of substituents in the reactor, it converted into the product having same stereochemistry. That means the cis dienophile gives the product cis product, and with the dienophile having the trans, then it gives the trans product. That means the stereochemistry get maintained in this Diels-Alder reaction. Let's take one example. Okay, this is the 1,3 product. This is just cis form. Okay, and this is the dienophile having substituents which are in the cis form. Okay, this pi 1 pair is shifted here, this pi 1 pair shifted here, new bond is formed here, eating the cis product is formed. Okay, new cyclic product is formed, and having cis geometry of a substituent. That means stereo gate retained in the product. This is the specialty of the Diels-Alder reaction. Next one is the mechanism of the Diels-Alder reaction. There are two mechanisms predicted for the Diels-Alder reaction: stepwise polar and free radical mechanism, and second one is the concerted mechanism. Okay, the stepwise polar and free radical mechanism involves the bond formation consecutively. It involves or it believes the bond formation take place consecutively, while the concerted mechanism, which is most accepted mechanism as compared to the stepwise polar and free radical mechanism, which involves or considers the bond formation take place simultaneously. Okay, let us see the polar mechanism. Let us see the stepwise in the stepwise polar and free mechanism. What is the polar reaction? What happens when the 1,3-butadiene reacted to the ethyl? This pi bond is shifted here, and the pi bond shifted here. This pi bond shifted here, and this pi bond gets shifted here. Okay, on the left to this carbon. So what happens? Such type of the structure is formed when this carbon achieves the positive charge, this negative charge. That means the diene is formed, and next one the cyclic product is formed. That means this transition proceeds. This reaction proceeds to the transition diene. That is the intermediate is formed. Next one is the free radical reaction. Okay, so which involves such type of the even breaking of bond, and by this bond, this pi bond is broken evenly, symmetric breaking. This is symmetric breaking. Radical is formed. So here is the radical is formed. That is diradicals are formed, and the product is formed. That means in the polar and free radical mechanism, one bond is formed, and then the next bond is formed. That means one bond is formed followed by another bond. That means the bond formation takes place consecutively. Okay. So, and the second one important is there is a formation of diene and diradical. That means the radical, diradical. That means this mechanism proceeds through the intermediate. Okay. So, not so important. Next mechanism which is constructed, which is highly important because it is acceptable and having evidences. So here the simultaneously bond making and bond breaking is occurred. So let us see, this pi bond is shifted here, this pi bond is shifted here, this pi bond is shifted here, and this mechanism proceeds to the 6-member transition state. Transition state is formed, simultaneous bond making and breaking occur, and the product is formed. Here the stereochemistry of the dienophile is maintained. That means these two groups are cis in the dienophile get retained in the cis in the product. That means this reaction is stereochemistry reaction. I think we have explained earlier. Okay, so this is all about the mechanism of the Diels-Alder reaction. Here the concerted mechanism is the most important mechanism because having proofs than the stepwise polar and free radical mechanism, and here in the concerted mechanism the simultaneous bond making and breaking is occurred, which proceeds to the transition state, 6-member transition. There is no formation of intermediate. Next for the application of Diels-Alder reaction. The Diels-Alder reaction has numerous applications in the synthetic chemistry. One is the synthesis of quinone and the polynuclear hydrocarbons. Okay, so 1,3-butadiene is reacted with naphthaquinone or the quinone. What happens? It undergoes Diels-Alder reaction and it forms such type of the quinones or the polynuclear hydrocarbons. Here the product is formed 5,8,9,10 tetrahydro 1,4-naphthaquinone. Second application, synthesis of alpha-terphenol. Okay, so intermediate first required for the synthesis of alpha-terphenol, which is the most important alkaloid, is synthesized by use of Diels-Alder reaction. Here the isoprene is reacted with methyl vinyl ketone in presence of the hydroquinone. It takes Diels-Alder reaction followed and form the intermediate first. This is cyclic product formed by the Diels-Alder reaction, which is used for the synthesis of the alpha-terphenol. Next one, the synthesis of the camping. Okay, this is the cyclopentadiene. Okay, reacted with vinylaldehyde, then it forms such type of the cyclic product which followed by or undergone through the number of steps, several steps, and it forms the camping. Next one, the synthesis of the cathepsin. Okay, this is furan. Furan is reacted with dicarboxylate acetylene. Okay, and it forms such type of the intermediate and which is used for the synthesis of the cathepsin.